So as mentioned earlier, I tend to introduce I'm the first talk because we're kind of the humble layer zero underneath all this. So we are the facility where the MOC runs. The MGHPCC is a data center and a consortium. We're a collaboration among 5 of Massachusetts' most research-intensive universities. So it's UMass, Harvard, BU, Northeastern, and MIT. And we built the facility in conjunction with the state of Massachusetts and 2 corporate sponsors, Dell EMC and Cisco. So we were conceived as a platform for collaborative research computing. So if you split that up, the facility is unique in its design for research computing. So research computing is different than enterprise computing. Pretty much in the type of workloads that we handle, our typical densities, rack densities, are 2 to 3 times what you'd find in an enterprise data center. And our largest densities are many times what you'd find in an enterprise data center. So we're specifically built for those types of compute loads. We're experimental by definition, so there isn't one. Some folks think of the center and think of like one giant computer. It's actually lots and lots of different computers. As Mark was talking this morning, I was thinking, gee, 2 sigma is huge, and then I thought, well, wait a minute, we can fit 4 of them in the facility. So we've got actually lots of different supercomputers in the building, and, but there's no single template for doing it. So being able to experiment with different architectures, different implementations was critical to the facility design. And then also, our researchers are frequently constrained by grant constraints or regulatory constraints. So when we built the facility, we took their security needs into consideration as well. On the collaboration side, collaboration is all about lowering friction. So we do that in a couple of ways. First and foremost, having everybody under one roof makes things a lot easier. It's much easier to collaborate between row 3 and row 5 than it is from Alston to Amherst. So just having everyone in one place makes collaborative research a lot more straightforward. We try to make the infrastructure as low friction as possible, so we pre-installed as much as we could. So the facility has pre-installed racks, structured cabling, power, cooling, all that's available. As a researcher, we like to think you just need to drive up with your tractor trailer full of computers and load them up and you're ready to go. And we like to think we have low friction process. As a data center operator, we try to make it as easy as possible for you to get your work done. And the nice thing about owning and operating your own data center is that if we're not getting our job done, you can kind of fix things. So, which you can't necessarily do at a commercial data center. All right, so quick by the numbers, we have to have this. We're actually a really great resource. We're a 100,000 square foot building. Oran doubled our size. We're actually only 1 acre of computing resources. We're a 10 megawatt facility. 10 megawatts is pretty big. 15 overall, if you take into consideration our peak capability. But 10 megawatts is roughly the same amount of power as 2 small New England towns. So we can host a lot of computers. The center has 758 racks when fully populated. That's about 33,000 rack units worth of compute. It's roughly split 80-20 between commodity compute and storage and critical compute, networking, and storage. And the split really is the 80% sits on really efficient, really inexpensive grid, direct street power, and the other 20% is on the more operationally expensive redundant power. So we have pre-installed racks. We have pre-installed structured cabling on the floor. Essentially, we have about 1,000 strands worth of, I don't know how you like to measure these things, 1,000 strands, 2 to 3 miles worth of pre-installed single mode and multi-mode fiber. That essentially lets us interconnect pretty much any part of the room to one another via cross connects. And then we've got about 1,000 linear feet of cable tray up and above that's tenant accessible above all the racks, which kind of gets you the last mile from the structured cabling and then also allows you to stitch together your clusters when you install your equipment. The center wouldn't be any use if we didn't have access to high capacity WAN resources. When we built the facility, we also built a 22-kilometer ring to pick up fiber that runs up the Mass Pike. It's a 155 strand ring, lands in manholes that are MGHPCC owned outside the facility. Obviously, if all of it were lit, it'd be about 10 petabits worth of capacity. Obviously, it's not all lit. We have services provided by MIT, UMass, and then we have commercial services provided by Comcast, Verizon, and Crown Castle's in there as well. So, so that's our networking infrastructure. And then, well, yeah, we have room to expand. So, The other acre, yeah, right. So we're actually built out on an 8-acre site. The facility takes up 4 acres of that. We have room to build another MGHPCC on the site as well. How we're green, green's in our name. It's really important to us. 94% of our power portfolio is renewables, so that's kind of first and foremost one of the ways we're green. In the facility design, we have a 1.2 PUE, that's our power usage effectiveness. It's a measure of the total power you use to the power that's used for compute. You'd like to see every watt go in to be used in compute. Obviously, that's not possible. You got to cool the building, you got to keep lights on, that type of thing. So your PUE is hard to get exactly 1. But we do pretty well. 1.2 is a really good number for the type of facility we are. We're a general purpose facility, meaning that you can wheel in your computer. We don't mandate anything about the clusters that you install other than maybe no open flames. But otherwise, you can bring in whatever architecture you want. We achieved this low PUE primarily because we take advantage of the fact that it's cold in New England. So we use free cooling as much as we can. About 60% of the year, we can run on just free cooling. We also, that chilled water that we make, we're very stingy about how we cool the computers. We use in-row cooling along with hot aisle containment, which is a very efficient way to cool the computers. Essentially, every 2 computer racks is 2 computer racks, an air conditioner, 2 computer racks, an air conditioner. And then we do hot aisle containment, which makes those heat exchangers very efficient. We keep the delta T across them very high. All right. Collaborative projects. We have a number of collaborative projects. Obviously, the Mass Open Cloud's there. We also have the C3DDB, which is the Commonwealth Cloud for Computationally Data-Driven Biology. I think that's the first time I've ever got it right in a presentation. So C3DDB is a life sciences cluster sponsored by the funding from the state. Engaging One is an NSF cluster that runs in the building as well. Northeast Storage Exchange, NESI, is a project we mentioned last year, a big, giant regional storage pool that's being built. We have another project we announced last year, which is also NSF funded, which is Cyber Team. Very cool project. We have these great cyber infrastructure resources. Big guys know how to use them. Not all the smaller to mid-sized institutions know how to actually get connected with them. So this team's specific job is to increase utilization of those assets by introducing those folks and helping them get on them. And then we've got a new project this year, Open Storage Network. NESI's very consolidated and huge. This is huge and distributed. And MGHPCC is one of the first 7 sites where that'll be deployed. I always mention this, we're a living laboratory. You can't usually walk up to a public cloud provider and say, give us all your data so we can do a research paper on you, but you can do that with us. And we've had a number of folks do that, thesis, journal papers. We've had some capstone project, class lab stuff. What's going behind the doors there? There are literally thousands of projects, so picking 5 is kind of arbitrary, but it gives you an idea of like the range of types of things that go on in the building. Everything from high energy particle physics with BU and Harvard and the Large Hadron Collider work, to food chain work being done at UMass, to materials and photovoltaic research at MIT. We have folks using the platforms for class, virtual labs in class. We also have entrepreneurs using the building as well to move their businesses forward. So. More projects. At the risk of running over my time, I always forget to mention this. We work closely with the state. We have for the last 6 years since opening the building. We work with DOT. We collect a lot of their data, do some data curation for them. They then take and do analytics on the data. They try to make the T run better. This is one of the sample projects. We like that idea. New one this year, we're working with their fledgling drones project to help them collect and analyze those data as well. And then education outreach, that's part of our charter as well. We have a whole lot of, there's 15,000 square feet of the building is dedicated to touchdown space upstairs, and then downstairs is a multi-purpose meeting room. In any given year, we go through between 20 and 25,000 visitors come to the building for various activities. Everything from, everything from Holyoke Codes, which is a great program and introduces kids to STEM, computing, and robotics. I think all of the Holyoke middle schoolers, I think, have been through the building as part of that. We have we're proud of our internship program. We added 5 new interns this year. Most of those are fed from the local community college, so Holyoke Community College and Springfield Tech. All those kids have gone on either to four-year colleges or to industry jobs, so we like that a lot. And I think that wraps it up. Yes, there you go. 1 minute. I came in 1 minute early. All right, that's it. Yeah, I'm done. I figured we were running late, so.